Hello and welcome to your trigonometry class. So today we're going to talk about basic trigonometric ratios. Now remember that a ratio is basically a fraction expression. So we're going to go over 3 examples. And then at the end of this video, I'm going to upload the practice problems that you're going to be working on. And this week's exam, or final exam, will be on all of the videos that I will be uploading, alright? So let's get to it. A ratio we know is a fraction, like I said at the beginning of the video. Now when we talk about trigonometric ratios, we're going to talk about the first 3, although the reality is that there are 6, and we'll see the other 3 in the next video. But the first basic trigonometric functions that we're going to talk about in right angle trigonometry is sine, cosine, and tangent. So in order for us to understand, we have this triangle here in which we have side A, side B, side C. Or angle A, angle B, angle C, followed by side A, B, and C. So what we're going to do is we're going to define or explain what trigonometric ratios are. So if we have the sine, remember from our previous video when we talked about the Pythagorean theorem, this was our short leg, our long leg, and our hypotenuse. And it's good for us to understand that because the sine, the cosine, the tangent are the basis of trigonometry. And they're going to be, of course, referent to whatever angle they're being asked to find. But, for example, if I say sine, and let's say I want to find out the sine of A. So we know that the function is SOHCAHTOA. So, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent, hence SOHCAHTOA. So if I want to look for the sine of A, I look at my angle A, and I look at, it says sine is opposite over hypotenuse. Well, I need to look at which side is opposite to A. Well, the side that's opposite to A is the side that's farthest from A, which in this case is the lowercase a, so we say A. And the hypotenuse, we said, is always C, so we say A over C. Now, if we're going to look for the cosine, and again, we're just working with A. Let's say we want to find the cosine of A. We look for the closest, it's adjacent over hypotenuse, so that means we're going to look for the closest side to A, which would be B, right here, and C, which is my hypotenuse. So adjacent is the angle closest, or the side closest. Hypotenuse is C, the side closest to angle A is B, and the hypotenuse is C. Now if I want to find the tangent of A, I have to look for the opposite over the adjacent. Well, the farthest side from angle A and the closest side to angle A, which would be capital A over lowercase b. Now, what if I wanted to find the sine, cosine, and tangent, but of angle B? I'm going to step out of camera for a minute, making sure that everything is working properly. Let me adjust the lens a little bit right here. Okay. Hopefully you guys can see that. Alright, so I'm sorry for that. If we wanted to look at sine of B, of angle B, okay? Now we look for opposite over hypotenuse, so the farthest sine, or the farthest side, from angle B is lowercase b, and the hypotenuse is C. So in this case you would say B over C. Now let's say I want to find the cosine of B. And if you notice, they're kind of like the opposite of what I did first. So the cosine of B, the side closest to angle B, which is A, over the hypotenuse, which is C. So we say equals A over C. Alright? And the tangent of B, which I'm going to write down here, and then I'm going to erase and go into our examples. The tangent of B, the side farthest from B, which is A, over the side, the side farthest from B, which is lowercase b, over the side closest to B, which is A. So that would be B over A. Alright, now I know this kind of seems a little abstract and we don't have numbers, so now in our next examples, we're not only going to just see this in terms of with numbers, but we're also going to see special triangles like 30, 60, 90, or 45, 45, 90, right? So let's get to it then, shall we? So I'm going to erase this. let's get started. Now we have this triangle right here. We have angle S, or triangle R, T, and S, right? And they want us to find the sine of R, the cosine of S, and the sine of S as well. Okay, so what I'm going to do is we're going to work with fractions. I'm going to leave the answers expressed. You can go ahead and look for a calculator to find the answers. Once again, I'm going to make sure that my technology is working properly and that the numbers are seen. All right, so if I want to look for the sine of R, I'm going to look for the number sine of R. If I look for sine, remember sine is opposite over hypotenuse. So the sine of R, the opposite is the number that is farthest from R between 12 and 5. Well, obviously that would be 12, so we would say 12. And the hypotenuse is 13. Remember, the hypotenuse is always going to be the larger of all three numbers. And if we divide that, that equals approximately 0.92. You can use a calculator to divide that, all right? Now let's look for the cosine of S. S is right here. So it would be the closest angle to S over the hypotenuse. So the closest angle to S is actually 12, and the hypotenuse is 13. Remember, cosine adjacent over hypotenuse. So 12 is the adjacent because it's the closest sine to S, and 13 is the hypotenuse. So interestingly enough, the sine of R and the cosine of S are both approximately 0.92. Now let's look for the sine of S. Now if I look for the sine of S, okay, remember sine, opposite over hypotenuse. The farthest number from S is 5, and the hypotenuse is 13. So we say, we divide that if you want to use a calculator, and if I'm not mistaken, this is approximately 0.42 if I'm not mistaken. So let's just divide to make sure. So I divide 5 and 13, and this turns into 50. Actually 0.38. The closest number is 13, 39. And that would be about 0.38. So this is approximately 0.38 if I use a calculator. Now, let's say I want to find the tangent. Let's say I want to find the tangent of R. Tangent of R. Remember that tangent is opposite over adjacent, so that would be opposite, which is, in this case, the number farthest from R, which is 12, over adjacent. So the tangent of R is 12, because it's the number farthest from R, so that's my opposite, and over 5, which is my adjacent. And I divide that, and that would, let's see, 12 divided by 5. The closest number I can use is 2. 2 times 5 is 10. Getting down to 2. So about 2.4 more or less approximately. You guys can actually verify that in your calculator. I don't have one with me right now. But I want you to understand the concept. The idea is to observe what I'm being asked. And then based on the information, use the trigonometric functions. Again, if I'm asked to find the sine of R, sine is opposite over hypotenuse. The sine farthest from R is 12. The hypotenuse is 13, so that's approximately 0.92. If I'm being asked to find the cosine of S, cosine is adjacent over hypotenuse. Adjacent being the closest side to S, which is 12. Hypotenuse is 13, and that's also 0.92. The sine of S, which would be the number farthest from S, which is 5, over the hypotenuse, so it's actually 5 over 13, which is approximately 0.38. And the tangent of R, R is over here, tangent is opposite over adjacent, so that'd be 12 over 5, which is approximately 2.4. Now, it's very easy when we have these generic triangles, but sometimes, and I'm going to step out of camera, pardon me, but sometimes we have these special triangles. Now, all the measurements inside of a triangle are supposed to equal 180 degrees. So sometimes you'll have triangles that are what we call 30, 60, 90 because, well, 30 plus 60 is 90 plus 90 is 180, or 45, 45, 90, where you have 45 plus 45 is 90 plus 90 is 180. Now you can use trigonometric ratios in these triangles as well. I'm going to do two real quick examples, and then you guys can actually go ahead and practice problems, see the rest. So let's look at the first one. Let's say I want to find the sine of, and this is actually, S, I'm sorry. The sine of 30 degrees, okay? Now remember that sine is opposite over hypotenuse. So I'm going to look for the side that is farthest from 30, which in this case is S, over the hypotenuse, which in this case is 2S. So we simply say sine of 30 equals the sine opposite, again, I'll just write opposite over hypotenuse so that you can follow me. Opposite being the side farthest from 30, which is S. Hypotenuse being 2S. And we simply, and I know this sounds redundant, but we're going to simplify it. S and S actually cancel out. And the sine, right, S and S can, remember that this is technically 1S. So S and S cancel out, and the sine of 30 degrees is actually 1/2. Again, sine of 30, the farthest side is S, the hypotenuse is 2S. Remember that S in reality is 1S, so what happens is that the S's cancel out, and that gives me 1/2. Now let's say I want to look for the sine of 60 degrees. What if I want to look for the sine of 60 degrees? Remember that the trigonometric function that we use is opposite over hypotenuse. So we're going to say equals opposite over hypotenuse, right? Which would be the opposite in this case. The farthest side from 60 is actually, and I'm going to do it right here. Let me actually continue it right here. So I'm going to draw this little arrow real quick. The sine of 60 degrees, opposite is actually S times the square root of 3. And the hypotenuse is 2S. So again, what's going to happen is that the S's are going to cancel out, and my answer is going to say that the sine of 60 degrees is actually the square root of 3 over 2. Now if you divide that in the calculator, it'll be 0.866. Stepping out of camera, making sure everything is working properly and that the video is not blanking out on me. You guys can see the examples. Alright, so again, sine of 30, 30 is over here, opposite over hypotenuse, S over 2S, because the hypotenuse is 2S, my S's cancel out. Remember that this is 1, so it's 1/2. And the sine of 60, which is the opposite of 60, the side farthest from 60, which is S times the square root of 3, over the hypotenuse, which is 2S. Again, the variables cancel, and I get the square root of 3 over 2. Now let's look at the 45, 45, 90 triangle. Now, if you notice, we have, and we'll use S as well. We have S times the square root of 2, S times the square root of 2, and we have 2S. Okay? So what we're going to do is we're going to find the sine of 45. So the sine of 45 degrees. The sine of 45 degrees. Again, sine is opposite over hypotenuse. Okay? So opposite would be the side farthest from 45, and in this case it doesn't really matter which side I choose because, oh, it's a 45, 45, 90. So I'm just going to say the square root of S, if I look at this 45, the farthest side is S times the square root of 2 over 2S. And again, my variables will cancel out. So that would just be the square root of 2 over 2. Now guys, something really interesting about the 45, 45, 90 is that the sine of 45 and the cosine of 45 are the same. Now let's look at the cosine of 45. So the cosine of 45 degrees. Now, in further trigonometry lessons, we'll see that there are special right triangles whose variables or whose trigonometric functions, I'm sorry, you'll have to memorize because, like in the case of 45, 45, 90, the sine and the cosine are the same because, again, cosine is s times the square root of 2 over 2s. The variables cancel out, and that would be the cosine of 45 degrees, which equals the square root of 2 over 2. And that's it, okay? So that's it for this basic trigonometric ratios video lesson. In the next video lesson, we'll discuss the other three and how to obtain those functions. Along with this video, I will upload your practice problems, so I'll see you guys very soon. Stay safe.